Alright, as you can see in my last video, in this series we want to install an E-turn supercharger on my Suzuki Vitara 1.6 8 valves with carbureted engine. The video on this link also explains why the conversion to EFI. Now let's start putting all the things together. This is the general wiring diagram of the Speeduino ECU. Here you have all the components that you can connect to the ECU. However, for some of them are mandatory, some of them are not, depending on your application. For simplicity, I will only address the components that are used in this project that I believe that covers most of applications. So for this project we will need a throttle position sensor, TPS, which tells the ECU if the throttle is closed, open or at any position between. Normally this is a potentiometer attached to the throttle valve that outputs a voltage or current proportional to the position of the sensor. Then for temperature readings we will need an inlet air temperature sensor, IAT, located in the intake manifold to measure the temperature of the incoming air, and a coolant temperature sensor or CLT. For any project like this, you will have to find the fittings for these sensors. In my case, and since there is a version of the Vitara which also uses the G16A engine but is full injector, I acquired a second-handed intake manifold and the throttle body of this version, which simplify the fittings. The throttle body and the thermostat goes here, and it has already a CLT and a IAT sensor. This body already has the TPS sensor, which is this little box here. I performed some little modifications to extract everything vacuum oriented and then replace the connectors. The other sensor required to this operation is the O2 sensor, also known as air-fuel ratio sensor or AFR, which measures the amount of oxygen coming out of the exhaust manifold. There are two types of O2 sensors, wideband and narrowband sensors. You can find a detailed description on O2 sensors in this link. Wideband sensors provide more reliable readings, but they are more expensive and require a wideband controller, so for simplicity and budget constraints I used a narrowband sensor. Unfortunately, I didn't film the O2 sensor installation, but basically what you need to do is to drill a hole in the exhaust manifold, weld a nut that fits in the O2 sensor, and then tighten the sensor in the welded nut. I have also installed an exhaust temperature sensor that might be helpful for tuning purposes. Finally, the most critical sensor required to Speeduino installation is the crank or cam position angle sensor. This sensor is the one that tells the Speeduino the exact position of the engine, so it can manage the fuel injection and spark ignition time. There are a lot of information about these sensors on the internet, but in short, these sensors are mounted near a gear wheel, and the sensor detects the gear wheel teeth using magnetic or optical properties. Typically, these wheels miss one or two teeth for reference. Well, at first, I was thinking in adapting this wheel to my crankshaft pulley and install the sensor there. However, this car is to be used mainly for off-road driving, and I felt that this critical sensor would be too much exposed to water, mud and everything that could enter the engine bay from below. So I removed the front of the car to get good access to the timing belts, removed the cylinder head cover and completely lose all the valves so I can rotate the camshaft freely. And then I made a decision that I hope that will not bring me problems in the future. Let's see. The decision was to install the position sensor in the camshaft wheel inside the timing belt box, protecting the position sensor from water and debris. I built a bracket for the sensor in a somewhat trial and error basis, and I believe that the fitting was quite nice at the time. The problem is that the Vitara camshaft wheel do not have any missing tooth, because do not have that purpose. Therefore, this sensor will read the wheel tip but it is unable to provide the exact position of the engine, and this was the decision that I hope that don't bring me problems in the future. So what I did was to partially grind one of the wheel tips, just the tip, so that the tooth was not read by the position sensor. Then I cleaned any existing sharp edges with sandpaper. From the timing belt point of view, I believe that there will be no problem, but removing this little material, I messed up with the wheel calibration and that might create vibration. Let's hope not. Finally, I powered up the sensor and tested it. I rotated the camshaft and acquired the sensor output 0. The sensor outputs 0 when detects a tooth. So here we can see that the sensor is detecting the 39 teeth that the wheels still have and misses the one tooth that we grind. Here we have a zoomed image. It seemed to be working perfectly, so I painted it to prevent rust and mounted everything into place. Let's back to this picture for now, because there is some information that we need to extract from it. The image is not perfectly centered, but when the camshaft is in this position, with this mark aligned with the mark on the cover, the piston number 4 is in the top dead center. Later, we will need to say to Speeduino the position of tooth number 1 in respect to the top dead center of cylinder number 1. So, if we put here an angle measurement tool, we have the tooth number 1 at around 180 degrees plus more or less 30 degrees. We will use this value and then fine tune it later with the stereoscopic clamp. To fit the sensor in the timing belt cover, I needed to drill a hole like this, but then I 3D printed a box to cover it, and after a layer of paint, this is the final result. I think it's pretty good. You can use the Speeduino to control a lot of things like thermal fan relay, boost control valve, among other things. But in our case, the actuators required to set the car running are the fuel pump, the injector, which is only one because we will use monopoint injection, and the ignition system, which in our case we will use a wasted spark type coil igniter. To explain every detail on what components you should use for your project would make this video very extensive, and it's not the purpose. But basically, you will need to choose a fuel pump that meets your specifications. In my case, the stock fuel pressure regulator opens at around 2.6 bar, and later I will want to build some boost, so I choose a pump with slightly higher pressure. The wiring is very simple. The Speeduino fuel pump output is connected to a relay that controls the fuel pump on and off. For ignition, I decided to use a Volkswagen Beetle type wasted spark system, which basically has two ignition coils, one for cylinders number 1 and 4 and other for cylinders number 2 and 3. The wiring is described like this on speeduino.com. I think it's pretty easy to understand. The only difference is that my coil pack includes 2 pairs of igniters, so only a power supply was required, and ENG1 and ENG2 fire each coil. The injector wiring is also pretty easy to understand. The 12 volts are supplied by a relay, and to set the injector open, the Speeduino sends a ground signal. In my case, I only used one injector, so I discarded this part of the schematics. The main problem that may arise here is if your injector is a low impedance injector. If we go to speeduino.com, we can see that only high impedance injectors are supported. Well, I measured mine and it has a 1.2 ohm resistance, so I used this link to calculate the current limiting resistor that I needed to use. Input my data and the result was a 8 ohm resistor, so I mounted a 8 ohm resistor in series with the injector. Please be aware that in these conditions the circuit current will be around 1.52 amps, so the resistor will dissipate around 18.5 watts. Make sure that you use a resistor that can handle that amount of power. With all the sensors and actuators in place, we needed to assemble the ECU and connect everything. I will not detail this part too much because, to be honest, I didn't do a very good job. I bought my board completely disassembled, so I started to weld all the components in place. I will leave a link here where you can see a detailed video on the board assembly, much better than mine. Then I 3D printed a box so I can develop my fuse and relay box to Speeduino circuit. And finally a box to the Speeduino ECU. I ended up replacing these plugs because I was afraid that they might not handle the currents needed. Which plugs you use and how you build the boxes depend on what you have available in your local hardware store. But what is important is the wiring diagram and the connections. The way that you wire each sensor to the Speeduino is available on speeduino.com. You go to Getting Started, select your board, and you will see the 40-pin connections to each sensor and actuator. For simplicity, I made a drawing of all circuitry. Here we have the Speeduino box and the 4-pin connector. The pin layout is not the same than that the board, but the pin numbers are the power pins, and here we have something that represents the connectors. These numbers mean nothing, I only use them for reference. Here I represented the power supply, battery 12 volts from ignition and ground, and the fuse and relay box. So this way we can see the interconnection between the sensors and actuators and the Speeduino and the relay box. And here we have the current limiting resistance in series with the injector. I will make this document available if you want to see it. Finally, to create the electric harness, the way that I found simpler was to connect the plug on the sensor side with a generous amount of wire length. I did the same to all the sensors and actuators in the engine bay, and then routed the wires to the Speeduino so I can cut them in the right size. The filming was not great, but in this snapshot you can see the excessive wire length and here the ECU. Then I cut all the wires, weld the terminals and wrapped the harness in tape. Well, everything is connected now, so it's time to open Tuner Studio, set all the required configurations and start the engine. Stay tuned for the next video. Thanks for watching, please feel free to leave your comments and subscribe for upcoming videos.